Welcome, calculus students. In this video, we're going to be solving problem number 1 from the Applications of Exponential Models worksheet. Number 1, let P of t represent the number of students in a school who buy their lunch after t weeks. Suppose P is increasing at a rate proportional to 600 minus P, where the constant of proportionality is K. Suppose 300 students buy their lunch initially and 400 buy their lunches after 10 weeks. A. Write and solve a differential equation that describes this situation. So let's start by picking out a couple key things. First off, we're going to write a differential equation. That means that it's going to be in the format of dy dx. In other words, we're starting with an equation for the rate of change. Now, the key part of this also is that we're increasing at a rate proportional to some amount. If you see a problem where it says rate proportional to, that means it's going to be in the model dy dx equals ky. In this case, we are actually given a function for y. So we're going to write our differential equation as dy dt, because this is in relationship to time, equals k, our proportionality constant, times 600 minus p. Now, as you learned in the previous AP classroom problem, the general solution to a problem of this type can be written as y equals ce to the kt power. So remember, this part we're multiplying by the k. That is our y. So we're going to replace y with 600 minus p equals c to the ekt power. Now our goal is to solve for c. In order to do this, we need to find some initial conditions given in the problem. We were told that 300 students buy their lunch initially. So we're going to put 300 in for P at time t equals 0. So 600 minus 300 equals c e to the 0 times t power. Simplifying that down gives us 300 equals c e to the 0 power. Remember, anything to the 0 power is 1. So 300 equals c. So we're going to circle back up and put that value in for c. Now our equation says 600 minus p equals 300 e to the kt power. Our next step is to solve for k. We're going to go back up to the initial problem and see what other information we can find. We were told that 400 buy their lunches after 10 weeks. We're going to put 400 in for P and 10 in for time. 600 minus 400 equals 300 e to the, I don't know, k, but my time is 10. So in other words, 200 equals 300 e to the 10k. We want to solve for k, which can look challenging because k is part of our exponent. In order to solve for k, the first thing we need to do is take the natural log of both sides. Taking the natural log of both sides gives us the natural log of 200 equals the natural log of 300e to the 10k. Before we work on solving this, we're going to take a break and let's review some properties of logs and exponents. Many of the challenges people have in these types of problems are more based in algebra. So take a minute to look at these exponent and logarithm rules. I'm not going to read them out for you. You might want to add these to your notes, or I will also put this image in the class. We're going to come back because we're going to use these. The first thing I want to address is that this part, the natural log of 300e to the 10k, looks a bit messy. I would really like to be able to separate that out. We can use this rule where the log of a product is equal to the sum of log m plus log n. So let's separate that out. So the natural log of 200 is going to equal the natural log of 300 plus the natural log of e to the 10k. You'll notice I still have k as an exponent. I would like to get that, I would like to get that k out of the exponent. So again, let's check out some of our log rules. The log of m to the n power can be rewritten as n times the log of m. So we can take that exponent, multiply it out in front. So this gives us the natural log of 200 is equal to the natural log of 300 plus, here's where I'm using that power rule, the 10k is going to go in the front, 10k times the natural log of e. Natural log and e are inverses. Remember, natural log is a log with base e. So the natural log of e is 1. So the natural log of 200 is equal to the natural log of 300 plus 10k. Now, I know at this point that it might seem tempting to just put that natural log of 200 and natural log of 300 into your calculator and solve it that way. Remember, on an AP exam, you don't want to simplify down until the very end. If you round too early, that's going to impact your answer at the end, and you're not going to be accurate to 3 decimal places. So let's figure out how we would solve for k. We're going to start by just subtracting the natural log of 300 from both sides. So the natural log of 200 minus the natural log of 300 equals 10k. Let's check out our log rules again to see how we can simplify that down. You'll notice here we have the natural log of m minus the log of n is equal to the log of m over n. That means that we can rewrite this as the log of a quotient. The natural log of 200 over 300 is equal to 10k. Okay, we want to solve for k, so we're just going to divide both sides by 10. And I'm also going to simplify down here. 200 divided by 300 is 2/3. So we have 1/10 times the natural log of 2/3 is equal to k. And now we are finally almost done. We're now going to substitute k in to the previous equation we had. If you scroll back up to your work, you're going to find that equation where we wrote p equals 600 minus 300e to the kt. Well, now we know k. So just substituting in our value for k, p equals 600 minus 300 e to the, now k was 1/10 natural log of 2/3 times t. Looks a bit messy, but that is our final equation. Notice how most of it was actually using algebra, not necessarily calculus. It was calculus that let us start with that differential equation and know what the general form would look like. Writing the equation is definitely the time-consuming part. B says, how many students will buy their lunch after 20 weeks? So we're going to start by just writing down our P equation from part A. T is our time at 20 weeks. So P will equal 600 minus 300e to the 1/10 times the natural log of 2/3 times 20 power. Now for some people, again, putting this in their calculator can actually be challenging. I have seen many students who have this correct equation and then have issues evaluating it on their calculator. So let's look at how I would do that together. So I'm going to work on evaluating that exponent part first. So on my calculator, if I want to find the natural log of 2/3, I have to start with 2 divided by 3. And then I'm going to hit natural log. So that is my natural log of 2/3. I'm going to divide that by 10. And then times it by 20. Okay, so that is my exponential part. And I want e to that power. So rather than rounding, I'm going to store this in my memory. Now on my calculator, to get e to that power, I'm going to use the second key. And actually mine will put e to that power when I hit this e to the x button. Okay, so e to that power is e to the 0.4 repeating. What we have done so far on your calculator was e to that power. Now 0.4 repeating, you may or may not know that that is the fraction 4/9. If you don't, you could simply type in 0.44444, keep going all the way out into your calculator. So now we can finalize this. 600 minus 300 times 4/9. This tells us that at 20 weeks, 466.667 people will buy their lunch.